Today I'm going to discuss with you Chapter 5, Sections 5.4 and 5.5. 5.4 deals primarily with the binomial distribution. We use the binomial distribution a lot in this course because it's easy to calculate the mean, standard deviation, and variance. These are on page 245 at the top. Your mean is n times p, your variance is npq, and your standard deviation, sigma, is the square root of npq. So they're very, very easy to calculate. You can use these like we've used them before to find unusual values. The definition for that is usual values fall in the range between mu, which is your mean, plus or minus 2 standard deviations away from that. Anything outside of that is an unusual value. Anything inside is a usual value. That covers 5.4. Next, we're going to look at 5.5, which is the Poisson distribution. And the formula for the Poisson distribution is on page 250 in the green box. With a Poisson, we need a mean, and the mean is usually calculated as the number divided by a time. Mean is usually done in tax returns completed per hour, phone calls received per hour, things like that. A classic example of a Poisson is a phone calling center. Phone calling center, they get phone calls all the time. A call center can only handle so many calls. So one might ask the question, when do I need to upgrade my phone system or hire another operator? You could use the Poisson to figure out what's the chances on any day I will exceed the number of phone calls I could handle and some would be dropped. So you could use a Poisson for that. Another classic example is bugs on a tobacco leaf. A farmer could collect some tobacco leaves, count the number of bugs, and that would allow him to figure out how many bugs he would expect to see on tobacco leaves. He could use that information to determine how much pesticide he should use, or if it's even worth his time to use the pesticides. And so that's what a Poisson distribution is. With the Poisson distribution, a lot of times you're going to be using a complement. Remember, your complement is always 1 minus probability of A. So we use the complement a lot with the Poisson because the Poisson goes on forever. It's another discrete distribution. It also uses Euler's number E, which is built into your calculator. So it's a pretty simple, straightforward formula, and it again is on page 250 in that green box.